All right, I believe that I can take the videos and make them YouTube videos and share the link, but I'm gonna see if I can find out why it's not shareable at the moment. But I am still gonna make the video so that we have it. All right, odd and even functions. I'm gonna make the video tonight for you guys. I'm sorry, it'll be for tomorrow. I know there's the chance some of you might not be able to get to it, but I'm gonna try to get it done as soon after school as I possibly can. Like, I'm planning on staying here and doing it here and not waiting to get till I get home, okay? So, I will figure out the video, getting it so that you have access to it, and then I will get that posted so you can watch the video for tomorrow, and tomorrow we're gonna see what the flipped classroom model looks like. Okay, so odd and even functions. Oh, and by the way, we are having a functions quiz on Thursday. It's gonna include lines and this only. Okay? That's all it's gonna include. Are you with me? All right, so odd and even functions. If I know a function is odd or even, I know more about the function. We utilize odd and even functions a lot in calculus because if we know more than just the bare minimum about the function. So we need to define what an odd function is and what an even function is. This first picture on the left, do you see that that has y-axis symmetry? That means if I folded the graph over on the y-axis, it would lay down on itself, right? Symmetry, remember when you started learning geometric shapes in elementary school or middle school and you would draw the lines of symmetry where you could fold it? This one has y-axis symmetry. So, if this function is f of x, do we see that f of a, that's this b value, is equal to f of the opposite of a? Do you see that those are the same? The y values have to be the same, otherwise it wouldn't lay down on itself when I folded it over the y-axis. Okay? So, this is what is known as an even function. And what the definition of an even function is that f of the opposite of x will always equal f of x. Always. So here's what's really cool about an even function. If I know f of negative 2 is 7, what does f of 2 have to be? Isn't this one the opposite of that one? Do you see how I know 2 points on the graph if I've only been given one, if I know the function is even? That's powerful. I know more information about the graph. Okay? You with me? Okay. This function has origin symmetry. This one is a little harder to see. But what origin symmetry says is that I'm going to use a different point to show this than the ones they show. But this, oops, let me do this point on the graph. So if I take any point on the function and I go through the origin and out the other side the same distance, I'm going to hit a point on the graph. That's what origin symmetry says. from any point through the origin, same distance out the other side, I'm going to hit the graph again. Okay? If I do that for this one, I should also see that that is the case. Oh, I should not do blue. Through the origin, out the same distance, I hit the point on the line. Okay? If I think of this as with symmetry, lines of symmetry, I would have to fold it over the x-axis and then fold it over the y-axis, and you see that it would lie down on itself. Neither of those are axis of symmetry, but if I folded it twice, do you see it would lay down? Another way to look at this when you did this in geometry, this has 180 degree rotation. Is that how you handled it? Is that, I'm not as familiar with that language. If I rotate this 180 degrees, I get the same graph. Okay. So here, would you agree that this is x and this is the opposite of x? Okay. I used A and B there first because the picture I found had them here. Here they're just calling it x and y, so I'll use those. So what do I know is true about f of x? Or sorry, f of the opposite of x? How does it compare to this f of x? Trying to get out of your way. This f of x is positive y. This f of the opposite of x is negative y, which means the function value is also the opposite. This is the definition of an odd function. Okay? So if I knew f of negative 2 equals 7, again, I know a point on the graph. What is f of the opposite of negative 2 going to be? It's going to be the opposite of whatever that function value was. So if I know one point on the graph, I know another. Does that make sense? Any questions on that? Anyone still copying the thing? So I want to determine whether or not these functions are odd or even, okay? And when I ask for you to determine whether or not a function is odd or even, or possibly neither, this is what you need to do. You need to use the definition. Do you see that both of those start with the opposite of f of the opposite of x? Do you see that? Okay. So we will start with f of the opposite of x. Doesn't function notation tell me whatever's inside that function notation is what I substitute in for x? If I said f of 2, what would you do? Put 2 in for x. If I said f of 17, what would you do? Put 17 in for x. If I said f of a, what would you do? Plug in a for x. This says f of the opposite of x. So I am going to substitute in the opposite of x into the function wherever x was. And now I'm going to simplify. What happens when I take a negative number to an even power? It's positive, isn't it? Minus 3 times. What happens when I take a negative number to an even power? What does that look like? If I'm not mistaken, that looks like f of x. So I started with f of the opposite of x, and when I was done simplifying, I got f of x. What does that tell me this function is? Not positive. Even. Okay? So you're going to tell me, therefore, I want to see that you start with f of the opposite of x. Simplify until you get this. And then therefore, the 3 dots mean therefore. Have you seen that before? Mathematicians are notoriously lazy. I could use 8 letters or 3 dots. Which one do you prefer? The 3 dots, right. So this means therefore. Oops, 9 letters. Sorry. Therefore, f of x is an even function. So let's do the same thing for g of x. We're going to start with g of the opposite of x. We're going to plug that in. What do I get when I take a negative number to an odd power? It's going to stay negative, right? Negative x cubed. And then what happens when I multiply a positive times a negative? Okay, this one we need to do one more step. Can I factor a negative out of both of these terms? When I divide negative x cubed by a negative, I should get positive x cubed. When I divide negative x by a negative, I should get positive x. What does this look like right here? Was that g of x? So did I get negative of g of x? Do you see that? So did I start with g of the opposite x and end at the negative or the opposite of g of x? So then I say, therefore, g of x is an odd function. Does that make sense? Now, you guys are trained pattern recognizers. And right now, I am feeling confident that there are at least a couple of you in here that have created a rule in your head already based on these two functions. Does anyone recognize something with a pattern for this?
Yeah.
Yes?
If it has an even exponent, it's an
Even function. If it has an odd exponent, then it is an odd function. Okay. So always, you think? Okay. So, if I did this one, you're telling me that's going to be an even function? Oh. Or what about this one? What if I said f of x is x to the 3/4? Odd or even? Are we gonna maybe be a little more careful about making rules in our head? Okay? We gotta test them, we gotta make sure. Now, what you did see was correct. If the function you are determining odd or even is a polynomial, all bets are off if we're talking other functions, okay? But if I have a polynomial and only even functions, even exponents, then I can say it's an even function. Or then I know that it is, but that's not your defense of it. Your defense of it has to be this. But you should recognize, oh, that one's going to be even. If your work doesn't work, double check it. All of my exponents here are odd. I probably have an odd function. Verify it. Okay? Let me do one more. I want to make one more. What's your favorite letter? Somebody. B?
I mean, I guess you can use anything but E of X.
What do we think this one is probably going to be? Neither. Probably going to be neither, right? Because it has an odd exponent and an even exponent. So let's make sure, and I want to show you the work, okay? So I'm going to plug in the opposite of x. Trying to keep that hidden. I'll do this. Fit it in since it's a different color. So then what I see is x to the fourth plus 2x cubed. Do you agree that that is not b of x? So it's not even. So the next thing I'm going to try is factoring out a negative, which gives me negative x to the fourth minus 2x cubed. And do I see that that is not equal to the opposite of b of x? Because this isn't b of x either. Do you see that? So therefore, not odd, right? So therefore, b of x is neither odd nor even. Do you see that I'm showing it doesn't equal what it would need to for an even function, and it doesn't equal what it would need to for an odd function? So, 2, 3 is on the graph of f of x. Oh, sorry. Some of you are probably still copying that down. I try to write stuff out every single time. I do not like to be the one that has the slides, that has all the work there, because I found that I can talk faster than you can write. Anyone? Have that happen? Yeah, so I like to write it out, but I still write fast. So, if I scroll, tell me, whoa, can you go back? I didn't get it.
That's my issue with note taking in every class ever.
Okay. So, if 2, 3 is on the graph of f of x, and I tell you f of x is even, what's another point on the graph? If I tell you f of x is odd, what's another point on the graph? We already kind of did that, so tell me that. Somebody I haven't heard from yet. Any idea? Another point on the graph if f of x is even. Eric.
-2, 3.
The x value is opposite, but the y value would be the same, right? How many of you got that? Here's the way you can go through that. That would mean f of the opposite of x equals f of x. Do you see the ordered pair? Somebody else I haven't heard from yet. What if f of x is odd?
-2, -3.
-2, -3. Again, because f of the opposite of x is going to equal the opposite of f of x. Does that make sense? Can you complete this graph if I tell you the function is even? If a function is even, it has y-axis symmetry, right? Finish the graph if f of x is even. Is that better? Okay, I'm not as worried that you have the size correct as you have the shape correct, okay? I personally, if I could have found a graph online that didn't even have a scale, I would have been fine with that. Did anyone do something like this? Look at how terribly wonky my graph is. Do you see that I understand what I'm doing? Okay, you're not going to be able to get it perfect, but I want you to get the shape. Okay, next one. What would the graph be if f of x is odd? It'll look something like that. Origin symmetry. Rotate it 180 degrees, right? Anyone still getting it? Which one do you want? Even, okay. Again, I care about the shape. Did you get something like that? What would it look like if f of x is odd? Does that make sense? Okay, we are not gonna have the quiz until after we have gone over the homework. And I think the homework is not posted at the moment because of the weekend. I have a break, fourth period, I will get the homework up there. Who are the people that I need to fix,